Company brain. Here is the thing nobody talks about with enterprise AI. Every vendor says knowledge management, but they mean search with a chatbot skin. That is not what YC is asking for. YC wants a company brain, a system that builds institutional memory over time, connects information across silos, and actually gets smarter the longer it runs. AitherOS delivers this with a 5-layer memory hierarchy modeled on how biological memory actually works, a 12-stage context pipeline that assembles the right knowledge for every interaction, and a self-improvement loop that turns every conversation into learning signal. Let me walk you through each piece. The problem: knowledge silos. 5 problems are on screen, and every company feels them. First, company knowledge is scattered across Confluence, Slack, email, and a dozen other tools. It is everywhere and nowhere at the same time. Second, RAG systems can search across those sources, but as the slide says, search is not understanding. Finding a document is not the same as knowing why it matters. Third, no existing system remembers why decisions were made, only what was decided. The reasoning, the trade-offs, the context all lost. Fourth, new hires spend weeks rebuilding context that walked out the door when someone left. And fifth, every AI assistant on the market has amnesia. Every conversation starts from zero. These 5 problems define the gap AitherOS fills. RAG vs institutional memory. Let me make this concrete. On the left, what you get from a traditional RAG system: 1 vector store, similarity search, no memory consolidation, every session starts fresh, and it finds documents rather than answers. On the right, what AitherOS delivers: 5 specialized memory layers, each serving a different cognitive function, retrieval that weighs similarity plus recency plus importance, a background daemon that strengthens important memories and prunes noise, memory that persists across sessions and gets better organized over time, and the ability to trace causal chains from a question to its answer through entity relationships. This is the difference between a search engine and a brain. The solution: 5-layer memory hierarchy. Here is the architecture. 5 memory layers, each modeled on a biological counterpart. Sensory buffer handles raw input voice transcripts, vision outputs, document ingestion, and filters before anything reaches memory. Working memory holds the current conversation context and active tool state. Semantic memory stores facts, concepts, and learned knowledge that persist across sessions. Spirit memory maintains personality, values, and behavioral patterns. And the knowledge graph connects everything through entity relationships and causal chains. At the bottom, the composable memory graph unifies all 5 layers into a single queryable graph. This is not a single vector store with 5 labels. These are 5 independent subsystems with different retrieval strategies, different retention policies, and different access patterns. Layer 1, working memory. Working memory is layer 1, the system's RAM. It holds the current conversation context, active tool state, and pending operations. The critical design decision here is per conversation scoping. When you are discussing a refactoring plan in one conversation and a deployment issue in another, those scopes are completely isolated. No context bleed. This feeds directly into the context pipeline stage 5, so the LLM always knows what is happening right now. The working memory service runs as part of the memory core compound service in production: 1 container, multiple memory subsystems. Layer 2, sensory buffer. The sensory buffer is the gatekeeper. Every piece of raw input passes through here before it reaches memory: voice transcripts from perception services, vision analysis outputs, document ingestion results, code analysis. And here is why it matters. Not everything that enters the system should be remembered. You see thousands of things every minute, but only meaningful signals make it to memory. The buffer applies relevance scoring before forwarding to working memory or semantic memory. This prevents noise from contaminating long-term stores. Without this layer, your knowledge base fills up with irrelevant fragments and retrieval quality degrades over time. Layer 3, semantic memory. Semantic memory is the long-term store, the system's SSD. On the left, what it stores: domain knowledge, user preferences, project patterns, API behaviors, and learned heuristics, anything that should persist across sessions. On the right, how it retrieves: not just embedding similarity like a basic vector store, but a combined ranking of similarity, recency weighting, and importance scoring. A fact that was relevant yesterday and highly important ranks above one that is semantically similar but months old. Background consolidation runs continuously, promoting important information from working memory into semantic memory, exactly like how human memory consolidation works during sleep. Layer 4, spirit memory. Spirit memory is the most unusual layer and honestly, the one that surprises people the most. It stores personality, values, behavioral patterns, and affect state. This is the firmware. It defines how the system responds, not just what it knows. Every agent has a distinct spirit. Demidage is precise and architectural. Lyra is creative and expressive. Athena is cautious and thorough. Spirit memory affects tone, confidence calibration, risk tolerance, and creativity level. This is what makes AitherOS feel like 43 different specialists rather than one model wearing 43 hats. Layer 5, Knowledge Graph. The knowledge graph is where the real magic happens. Typed edges connect entities, caused by, depends on, decided at, owned by. Every fact links to its source and timestamp. When you ask why did we choose PostgreSQL over MongoDB for the user service, RAG might find a document mentioning the choice. The knowledge graph traces the full causal chain. The decision was made at a specific meeting, driven by a performance benchmark, influenced by a scalability requirement from the product roadmap, owned by the platform team. That is the difference between search and understanding. And because every edge is typed and timestamped, you get provenance for free. 12-stage context pipeline. This is the 12-stage context pipeline. Every single LLM call in AitherOS goes through this assembly process. Stage 1 loads Axiom's fundamental rules that cannot be violated. Stage 2 loads the agent identity. Stage 3 layers in behavioral rules. Stage 4 checks capability grants. Stage 5 brings in task-specific context from working memory. Stage 6 retrieves relevant memories from semantic and spirit layers. This is already richer than most systems' entire context window. But we are only halfway. Context pipeline, stages 7 to 12. Stages 7 through 12 complete the picture. Affect captures the emotional state and confidence calibration from spirit memory. Will applies policy overlays based on intent classification. Knowledge brings in domain facts from the knowledge graph and base knowledge. Web search adds real-time results when the query needs current information. Recent conversation provides continuity. And response format sets the output shape structured JSON for MCP callers, natural language for humans. The result is a system prompt that went from around 3,000 characters to over 7,000, with full organizational context on every single call. This is why AitherOS responses feel deeply contextualized in a way that single-purpose chatbots simply cannot match. Code, context pipeline assembly. Here is the actual code. 12 stages, cleanly separated. The first 4 stages are deterministic same agent, same grants every time. Stages 5 through 8 bring in dynamic knowledge that changes with every request. Stages 9 through 12 add external data and set the output format. Notice the async calls, context, memories, knowledge, and web search all hit external services. The pipeline handles timeouts and fallbacks at each stage. If web search is slow, it proceeds without it rather than blocking the entire response. This is production code running in every LLM call, not a prototype. Composable memory graph. The composable memory graph is the unification layer. It connects entities across all 5 memory layers into a single queryable graph. When you ask what do we know about the authentication system, it pulls from working memory for current conversations about auth, semantic memory for learned facts about auth patterns, the knowledge graph for entity relationships in the auth service, and spirit memory for how the system typically reasons about security topics. No individual memory layer could answer that question alone. Together, they produce institutional memory. Memory consolidation daemon. The memory consolidation daemon is inspired by how human memory consolidation works during sleep. 2 operations shown on screen. On the left, strengthen. Frequently accessed facts get promoted from working memory to semantic memory, cross-referenced information gets linked more strongly, and high-importance signals are prioritized for long-term storage. On the right, prune. Rarely accessed facts have their retrieval weight decayed, noise gets filtered from results, stale information is deprioritized, and the system gets cleaner over time rather than accumulating clutter. After 6 months in an organization, the memory hierarchy reflects what actually matters, not just what was recently ingested. Knowledge support services. 4 supporting services complete the knowledge infrastructure. Knowledge cache provides tiered caching with freshness scoring. Not just is this cached, but is this cache entry still reliable given how old it is and how volatile the source is. Context deduplicator prevents redundant context from flooding the LLM window. If 3 memory layers return the same fact, it appears once with merged provenance. Documenting Aitherium handles the pipeline from files and URLs to memory parse, chunk, embed, route to the appropriate layer. And Conversation Profiler extracts patterns from chat history to improve memory retrieval over time. Self-improvement loop. The compound flywheel. Predict. JEPA estimates what will happen next, what the user probably wants, what information will be needed. Observe. Violation of expectation scoring detects when those predictions fail, when the retrieved context was wrong, when the user needed something different. Improve. SEAL generates targeted training data from real failures, not periodic retraining on generic data, but focused improvement on actual mistakes. Accelerate. Improved models run faster on optimized kernels, reducing inference cost. Each cycle produces training signal for the next. After a year of operation, the system has learned which questions lead to which follow-ups, which decisions have which consequences. Compound growth, not linear. Competitive positioning. On the left, the competitors. Glean offers a single search index across SaaS apps, no agents, no memory hierarchy. Notion AI is a sidebar for document Q&A, not institutional memory. MEM.AI provides notes plus search with no reasoning engine. And Microsoft Copilot is vendor-locked to Office with no self-hosting option. On the right, what AitherOS delivers: 5 memory layers with background consolidation, a 12-stage context pipeline, 43 agents that act on knowledge rather than just retrieve it, a self-improvement loop, and sovereign deployment. The gap between search and understanding is where AitherOS lives. Evidence table, memory infrastructure. The evidence. 13 memory microservices in services memory, all built and running. 30+ memory library modules in lib memory retrieval, synthesis, scoping, deduplication. The context pipeline with all 12 stages built in libcore context pipeline.py. Context X-ray for pipeline snapshot, replay, and ablation testing built in lib orchestration context X-ray.py. The JEPA world model and SEAL self-edit engine are designed with architecture slots in the codebase integration pending. The main gap is a customer-facing knowledge upload UI. The document ingestion pipeline is built, but it needs portal pages for non-technical users. Gap analysis. For gaps to acknowledge honestly. Medium. The JEPA and SEAL improvement loop is designed but not in production. The architecture slots exist, the trainer and evolution services are built, the integration is pending. Low. Cross-tenant knowledge isolation has been verified for working memory, memory core, and Nexus, but the graph RAG layer needs confirmation. Medium. No customer-facing knowledge upload UI. The document ingestion pipeline exists but needs portal pages. Low. Memory consolidation has not been tested at organizational scale. The daemon works in testing but needs load testing with real company data volumes. All gaps are scoped and have clear mitigation paths. Company brain. Summary. Here is the bottom line. AitherOS delivers on the company brain category with a 5-layer memory hierarchy that actually functions like memory: working memory, sensory buffer, semantic store, spirit layer, and knowledge graph. A 12-stage context pipeline that brings the right knowledge to every interaction. A memory consolidation daemon that strengthens important memories and prunes noise, just like human sleep. A composable memory graph that unifies all layers into a single queryable structure. And a self-improvement loop that turns every interaction into learning signal. 13 services, 30+ modules, all built. This is not RAG with a fancy name. This is institutional memory.